We want to solve the quadratic equation without using the quadratic formula, and it is the easiest way that you can solve these equations without knowing any formula. We just need to know that if say x1 and x2 are the roots of this quadratic equation, then their sum is minus the coefficient of x divided by the coefficient of x squared, and their product x1 times x2 is c over a. If we know these relations, we can solve the quadratic equation in a very easy way without knowing the formula. So let's note that from the first equation, from the fact that the sum of the two roots is minus b over a, we can conclude that the average of the two roots, x1 plus x2 over 2, the average is equal to minus b over 2a. Let me call the average m. Now, suppose x1 is the smallest root and x2 is the larger root, then m, their average, is exactly halfway between these two roots. And let me call these distances, which are equal to each other because the average is exactly halfway between the two roots. Let me call this distance h. And since h is a distance, we can assume that h is positive, or at least greater than or equal to 0, because I mean x1 and x2 can be equal to each other. In that case, m will also be equal to both of them, and x1 and x2 can even be complex numbers. Still, the calculation that we are going to show will work. So we know the average of the two roots. It's minus b over 2a, and well, x1, the smaller root is m minus h, and the larger root x2 is m plus h. Now, m minus h times m plus h is x1 times x2, which we know is equal to c over a. Now, we know m, we know c, and we know a. Everything here is known except h. And m minus h times m plus h is m squared minus h squared. This is the conjugate identity. And from this equation, we can find h, and we can easily find x1 and x2, because if we know h, then we already know m, so x1 will be m minus h and x2 will be m plus h. Let's use this in an example. So suppose we want to solve this equation, x squared minus 2x minus 3 equals 0. Then m is minus b over 2 times a, which is 2 over 2 is just 1. So m is 1. And, well, we know that x1, one of the roots, is 1 minus h, and x2 is 1 plus h. Now, 1 minus h squared, which is 1 minus h times 1 plus h, it is equal to x1 times x2, which is c over a, which is minus 3 over 1. It's just minus 3. So 1 minus h squared is minus 3, so h squared is 1 minus 3, which is 4. So h is either plus 2 or minus 2, but remember we assume that h is positive, so we take h equals 2. And from this we can see that the first root is 1 minus 2 is minus 1, and the second root is 1 plus 2, which is 3. So the two roots of this equation are 1 and 3.